Hello.
Yes, sir.
Yeah. So the topics that we have discussed so far include normalization. Then we had discussion. We had a review regarding the join operator, relational algebra, and then we came to the importance of distributed databases, and we have seen different protocols related to distributed databases. Then we have seen the architecture of distributed database or DDBMS, distributed database management systems in the last class. So then we have seen that, when to go for it. We had a comparison between distributed databases and uh, centralized databases. And we have seen there are basically uh, some contradictions which are coming in the context of distributed databases when compared to centralized databases, because in the case of distributed databases you take redundancy as a plus point, or if there is an important data you don't mind replicating the data, whereas in centralized databases replication is normally considered as a crime, or it is a weakness which you would like to minimize or if possible eliminate. So the ultimate idea in centralized databases is to have only one copy for one piece of data. So that is actually the aim in distributed, in centralized databases. All right. So this topic, actually the concurrency control, we have studied as part of the distributed computing course. It is coming in the topics in databases class also. So it will also be a review more or less. Those who have taken the distributed computing course, the same topic we are discussing it here. And those who did not, for those who did not attend the distributed course, this will be a new topic. So, as I was mentioning in one of the previous classes, that almost all problems in computer science are basically these optimization problems. So here also, when you are talking about databases, you are trying to optimize certain parameters. So can some of you help me in identifying the parameters which one is trying to optimize in a database environment? Ajwad, can you tell a parameter which is being targeted for optimization in the context of distributed database?
Query optimization is concerned.
Query optimization. So basically the parameter is the query processing time you would like to minimize.
Yes, sir.
Also the memory utilized during the query processing you would like to minimize. Okay. Anakha, you have any other parameter which is a target for optimization?
So memory.
Memory in which context? Ajwad was talking about query optimization, or query evaluation or query processing time. You would like to reduce the memory. Can you tell the context where any other context where memory needs to be minimized? Anaka?
Uh,
Okay. Other. Other.
Sir, I don't recall anything beyond 20.
Pardon? I'm unable to hear you.
Sir, I don't recall anything beyond this time required for query.
Okay. Avinash,
Yeah, yes, sir. So, sir, actually, what we can do is we can use try to divide the tables in many parts so that the memory can be utilized properly.
okay. Yeah, during query processing, you try to minimize memory, and during data storage also you would like to minimize the memory because especially in the context of big data applications, one cannot think of duplicating the data everywhere because big data are considered to be data of huge volume. So my initial question was the parameters which are one is trying to optimize. So memory we have seen, time we have seen, any other parameter, Avinash?
Uh, I think, sir, maybe the cost of actually the cost will be time and memory only.
Okay, but you would like to minimize the cost of query processing. Okay, that can be in terms of parameters. As you said, it actually consists of the time taken and cost, I mean memory, but it is another parameter. Good. Anojna, yeah, any other optimizing parameter which people try to optimize, either maximize or minimize.
Communication costs, sir.
Communication cost you will try to minimize, but it will, yeah, good observation, but it get translated to the query processing time, which Ajwad was telling at the beginning. All right. So what is the project that you are doing, Manojna?
We are doing ranking and discovering the most influential product on e-commerce, sir.
Okay. So do you have any optimization parameter there? So when you develop a technique, which you will try to make it good or above some bar?
I think we will be optimizing the ratings, sir.
Optimizing the rate. I mean, you are trying to, what is the problem on the e-commerce side? You try to
Ranking the products, sir, like based on the reviews and ratings we get from the users, we have to find a technique to rank the product.
okay. So there, I think you are you will be trying to make it more and more accurate, isn't it?
Yes, sir. Yes, sir.
Your accuracy, I mean, your ranking should be accurate. So I can say that probably accuracy is the optimization parameter. I come up with a method where the accuracy is 60%. But if you come up with a method where the accuracy is 75%, definitely your method is better. So there the optimization parameter is accuracy. So what I am trying to say is that almost all problems in IT or computer science on applications are optimization problems. So in the context of database applications, one important parameter which everyone is trying to optimize, not only in the database context, most of the applications is actually the throughput, number of successfully completed activities over a period of time. So if you take the railway reservation, nobody will look at the beauty of the ticket which is being printed, or nobody will look at how what is the aesthetics or the user interface, how good it is, etc. Of course, they are important, but everyone will try to get the reservation done in few seconds, if possible in milliseconds. And you will also try to do the cancellations, preponement, postponement, everything in less amount of time. So what is happening is if you do it in less amount of time, the number of reservations per minute or the number of cancellation per minute can go high. So that is actually the throughput. So the concurrent access are allowed on the database basically to optimize the throughput of the application. All right. So more
Excuse me, sir.
concurrency. Yes.
Sir, what
Vishal.
about data transmission, which was significantly reduced using semi-join? Will that be part of query optimization or separate itself?
Yeah, actually all these parameters are interrelated. So it will be part of query optimization. It will be part of communication cost reduction, and it can be part of throughput also. Because if the communication delay is reduced, you will be able to complete the activity as early as possible. All right. So the semi-join operators are, I mean, it is actually a tool or a mechanism which can contribute to query processing, which can contribute to communication cost, which can contribute to throughput, which can contribute to optimization, all these things. Is it clear, Vishal?
Yes, sir. Yes. Okay.
Yeah. So all these things are related. So here you have something called transactions. A transaction is actually a collection of statements which are specifically for a particular activity. For example, at the end of the semester, so the instructor of a course has to prepare the uh, grade sheet. So he will feed all the interim marks, internal assessment marks. He will enter the end semester mark and he will enter the attendance grades. And then he will also enter the grade criteria. That is above 90, 90 to 90, 90 to 100, yes, grade. And say 80 to 89, A grade. 70 to 79 B grade. So like that, he will enter that and give us input the name, roll number, internal marks of the students and end some mark and the attendance. Then it will automatically calculate the grade sheet. So the whole thing can be called as a transaction. Maybe I can say the grade sheet calculation is a transaction. So there you have series of steps. First feed the internal mark for each of the 40 or 45 or 55 students. Then enter the end semester marks. Then enter the total attendance. Then enter the uh, grade criteria. Then enter the attendance grade criteria. Then go for the generation. So there it will add internal marks with end semester marks and then it will look at the attendance also and then according to the grading criteria it will give the calculate the final grade. So while calculating the grade, why do you want to check the attendance grade also, Chetana? I'm talking about the NITC system. I'm just checking. Why do you want to check the attendance grade while you are calculating the course grade? Just casual question.
Because maybe it have some maybe it attendance
What are the
based
attendance grades that one may get?
sir, can you repeat?
What are the different attendance letter grades that one can get at NIT Calicut?
Attendance?
Grades, letter grades. You have an
Uh, le-
attendance grade also, na, in your semester mark list.
yes, sir.
Grade sheet.
Yes, sir.
What are those attendance grades?
Sir, L, N, and H.
L, N, and H. Okay. So if you have L, attendance is low, then
Yes,
what
sir.
can be your grade?
Can affect the total grade.
No, you won't get the total grade. The attendance is L means you have below 80%, then you will not be getting the actual grade. It will be, I think you will be getting I or W. W grade means want of attendance. All right. Am I correct? Anyone? If the letter grade, I mean attendance grade is L, automatically the DSS, the software is programmed to make sure that you are not getting the actual grade according to your marks. It will automatically become W. W means want of attendance. So then even if you got 95, your grade will be W and you may have to repeat the course. So that is actually the business rule that is followed in the system. All right. So anyway, what I'm saying is a transaction is a series of actions which are performed on a specific database. So these things are known to you. So the transactions normally follow the ACID properties: atomicity, consistency, isolation, and durability. So from this, I think atomicity, consistency does not require any explanation. Maybe we will just, maybe Tarun will tell us about isolation. What is this isolation, Tarun?
So set of transactions that which are executing in the system at once, like they will be invisible to other transactions. Like if 3 transactions are executing concurrently, the other 2 transactions will not know about the other transaction which is executing in the system.
So what do you
Like
get
the
out of it?
like the result should be serializable to some series of execution of transactions.
So what actually you are doing for getting isolation?
We are locking the data items and making sure that on the same data item, multiple transactions are not executing at once.
No, that is not the thing. You will be allowing other transactions also to work on the data item.
On the same data item, sir. At the same data item, we don't normally do multiple write operations, right?
Okay. Yeah, Sunita, can you add something more to what Tarun has said?
Yeah, sir. Each transaction is executed independently.
You are not. It is not clear, Sunita. Hello. Yeah.
Hello.
Yes, you are audible now.
Each transaction means each transaction is executed independently.
Okay. So what happens is when I am making some modification on a data item, and if you are also trying to get the same data item, then my changes should not be visible to you. Suppose I have done 5 cancellations and later I just reverse it. Then what will happen is you will also have to reverse your operations. So if A is doing something which is accessed by B and what B is doing is accessed by C, and now what happens is A rollbacks or A cancels whatever it has done, then B has to cancel. Then B is canceling means C also has to cancel. So like that. So there will be a chain reaction if you allow partial data to be allowed accessible to other transactions. So when till a particular transaction has completed or it is committed, other transactions should not read in between values. That is what isolation means. Durability means committed updates should continue or it should persist. All right. So these are the 4 properties which are known as the ACID properties. So just read what is actually this atomicity. I am sure you know that. So you can spend 2 minutes on this. an important property, atomicity. Okay, so it should be either completely done, all or none. So that is actually the property here. So you will be either redoing or you will be undoing a particular transaction on occurrence of errors. All right. So consistency, I think there are two different types of consistencies. A transaction T does not overwrite dirty data of other transaction. Dirty data refers to data values that have been updated by a transaction prior to its commitment. All right. So degree 1 means T does not overwrite dirty data of other transaction. T does not commit any writes before end of the transaction. Just read it thoroughly. Okay, so there are two degrees of consistency, degree 0 and degree 1. Isolation. So if several serial, I mean, it has got two different aspects, serializability and incomplete results. So just read the details of these two. What is serialization and what is incomplete result? All right. This also, serializability means if several transactions are executed concurrently, the results, the end result must be same as that of some serial execution. Some serial execution. It may not be always in the same order, but it should be equivalent to some serial order. An incomplete transaction cannot reveal its result to other transactions before its commitments. This is actually called, this is also part of what is known as isolation. All right. Durability means once a transaction commits, the system must guarantee that the results of its operation will never be lost in spite of the subsequent failures. All right. So that is actually called durability. And you should be able to recover any piece of data. So as I have said, no database management system can ensure that there will not be any failure, but the DDBMS at least ensures that any data which is entered into the database can be recovered even if there has a failure occurred. Right? Now let us see the term workflow. So what are workflows in a distributed or in a concurrent database context? Just read about the three different types of workflows. Human-oriented workflows, you have system-oriented workflow, and you have transactional workflows. These are mere definitions. Just read them and convince yourself. Human-oriented workflows, system-oriented workflows, and transactional workflows. All right. So when we are processing the transactions, there are concurrency control protocols and also there are replica control protocols. Okay, so the concurrency control protocols or concurrency control algorithms are basically on how to synchronize concurrent transaction executions. How can we make the end result consistent? As some of you were saying, if you are correcting the data in a database parallelly or concurrently, you have to make sure that all those corrections or all those changes are reflected on the data in the correct order. So intra-transaction consistency and isolation are very important. Then replica control protocols, it deals with how to control the mutual consistency of replicated data. All right. So how to control the mutual consistency of replicated data? That is actually the topic which is being discussed under the replica control protocol. So here comes the internal how a particular application is being executed in a distributed database. So just spend some few seconds or maybe 1 minute on this particular slide just to see what exactly the environment in which a distributed transaction is being executed. So what are the different modules? Just go through that. Okay, you have different boxes. You have a transaction manager and you have a concurrency control protocol handling module and you have a recovery manager. So there happens peer interactions. So this is actually the distributed transaction execution model. All right. So this is there are basically two different approaches in distributed concurrent transaction processing. So first approach is actually when you talk about concurrency control, there are basically two approaches. One is actually the pessimistic approach and the other one is actually called the optimistic approach. So you have pessimistic approach and optimistic approach. The pessimistic approach, you are afraid that someone will access the data while you are accessing the data. So what you do is you lock the data item and till your work is over. Then you unlock it so that other transactions can access. And in the optimistic concurrency control, you are very much optimistic that even if you allow other transactions to access the data, nothing is going to happen or no consistency issue will come. So you allow others also to work. So first let us see the locking protocols, which is actually a type of pessimistic control approach. So Deepak Milan, can you just tell what is this symbol lock protocol? I think you did the distributed computing course also. So can you just tell what
Yes,
is
sir.
this lock unlock protocol?
Simply like if you want to access a data item, you have to lock it, and I mean for writing, and uh, after the writing is done, you can unlock it.
Okay. So will you look at what type of operation that you are going to perform on the data item?
Uh, yes, if I want to write, then only I will lock it. For reading, I don't think so. Lock is required.
All right. Hello, Laushe. So what are the operations? Whether the symbol locking protocol distinguishes between the operations performed on the database?
Sorry, sir.
Hello. Yeah. Can you just tell about that?
Can you repeat, sir?
Yeah.
Can you repeat, sir?
Yeah. Whether in the symbol lock protocol, the operation which the transaction is going to perform on the data item is considered or not?
Not sure, sir.
Okay. Satya, Lakshmi Shetty, Satya.
Yes, sir.
Yeah. So what type of operation is performed is considered here in the symbol locking protocol?
Right operation, sir.
Are you consider the protocol is considering that or not?
Yes, sir.
Okay. Then what is the difference of the first one, symbol lock protocol with the read lock one, write lock all protocol?
In the second one, while we are obtaining a write lock, we'll be locking all the shared copies of that particular data, sir.
When you are performing the read operation,
We lock the one which we are currently reading, the copy which we are currently reading.
so how is it different from the first protocol? Symbol lock protocol.
In simple lock protocol, we'll be locking all the copies, sir, irrespective of the transaction. After the transaction is completed, then we'll unlock. Sir.
Is it irrespective of the transaction?
I think so, sir.
Yeah, it is irrespective of the operation.
Yes, sir. Irrespective of the read or write operation,
Right,
we'll be locking
exactly.
the.
That is the answer that I was looking for. So irrespective of whether you are doing a read operation or write operation, you simply log the data item. That means when you are reading, then also you log the data item and prevent others from accessing the data. Whereas in the case of RLOG1, WLOG all protocol, so the idea is that you look at the operation, what operation you are going to perform, and accordingly you decide to log either one copy of the data item or copy all the or log all the copies of the data item. So if it is a read operation, you will log only one copy, whereas if you are performing or if you are coming across a write operation, all the copies will be logged. So read log one, write log all is actually a modification of the first protocol, which is actually called the symbol log protocol. All right. I hope the difference is clear. So the second one is having two different or three statements altogether: R log, W log, and U log. U log is for unlock. Now look at majority locking protocol and give your comments. What is majority locking protocol? So what is this majority locking protocol, Megha? Megha?
Sir.
Yeah, what is this majority locking protocol?
Majority locking protocol like same behavior with both shared lock and exclusive lock, like read and write lock. Responsible for locking and unlocking the data. This is called majority protocol.
Majority, okay. Fasil?
Yes, sir.
Yeah, can you just tell what is majority locking protocol?
It has same behavior as like shared lock and exclusive lock. I don't think any idea.
It has got the same property as
Shared locks and exclusive lock.
no, I did not hear that part. Same as
Shared locks and exclusive lock.
shared lock and exclusive lock. Okay, so the thing is that in majority locking also you have the properties of the first two protocols, symbol locking protocol and the read lock one, write lock all protocol. So here again you don't look at the operation, whether you are performing a read operation or write operation. That is not considered, but you will be irrespective of the operation, you will be locking n by 2 plus 1 copies. If there are n copies, you will be locking n by 2 plus 1. If there are 10 copies, you will be locking 6. That is the majority, at least 6 data items. Then you call it the majority locking protocol. So here in read operation as well as write operation, uniformly you will go for n by 2 plus 1 writes, locks. So that is actually called majority locking protocol. Then there comes the M out of n protocol, which is actually a generalization of majority locking. So Neetu, can you just tell what is this M out of n locking?
Yes, sir. If there is out of n datas, we will be locking m. It is like a generalization of the majority locking protocol. Like if you are using n by 2 plus 1, then it will this m out of n copies will be equal to majority locking protocol.
Okay. So M out of n means M can be an integer anywhere between 1 and n. All right. So if I set M is equal to n by 2 plus 1, it will become which protocol, Neetu?
Majority locking protocols.
Majority locking. If I put M is equal to 1, then
Symbol
it will
lock.
be symbol locking protocol. That means lock, maybe, yeah, at least for the read operation, it becomes the symbol locking protocol. All right. Or I can say, yeah. So M out of n is actually generalization of the majority locking protocol, and so it is actually a generalization of the first protocol, symbol lock protocol. All right. Then master copy locking and master node locking. So this also we have studied in the last class. So I will like to get it defined by Piyush Abhishek. So what is
Hello, sir.
master copy protocol?
In this, like we kept one copy as a master copy,
Okay.
and then changing the data on the other transactions, sir. Locking other data items for that transaction. Like if we take an example, sir, if we say that in Delhi or Bangalore. In Delhi, some master node is there, sir. Master data is kept there. We does not change that data item. We change on simple data items.
Okay. So any one copy of the data item will be designated as the master copy. So for at any point of time, the value of the data item in the master copy is considered the latest as well as it is considered as the official value.
Accurate one.
That is actually called the master copy data.
And in master node, then we put one node as the master node
for a particular data item. For example, I can say the server or the node at Indo is actually the master node for something. Or let us say in the railway reservation system, I put the Madgavan or the Goa Madgavan server as the master node for say some train, say Konkan train. I mean some train which is going via Konkan train. So that is actually the master node locking. So what is the problem with master copy and master node protocols? Praneeth Kumar.
Sir, if this master copy or master node is compromised, then there might be an inconsistency in the database, sir. Because if there is a problem, like every other node will be referring this master node or master copy. So if itself is a like not a consistent one, then there would be inconsistency in the whole database.
All right. So if the master copy or the master node is either down or it is not available, then even if you have 100 other copies of the data, you will not be able to do anything because whenever you make an updation, it should be updated either on the copy at the master node or on the master copy directly. So it is going to be a very crucial thing. All right. And it also suffers from the central point of single point of failure. If the node containing the master copy fails, the whole thing has failed. And if the master node is failed, then the whole applications are down. So both suffer from the single point of failure. Then you have the MGL locking scheme, multi-granularity locking. So what is this multi-granularity locking? Celeste.
So I think it's allowed data items to be the various size to define the hierarchical data.
So what do you mean by multi-granularity?
Multi.
You were there in the distributed computing course, isn't it?
Yes, 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 sir.
So you will be able to tell.
I'm not sure. I'm not sure.
All right. So you can divide the data into different granularity levels. So you can talk the data in terms of the column level, or you can talk in terms of the tuple level, or you can talk it in terms of a few set of records level, or you can talk in the case of a tabular level. So like that, there are different granularity levels for a particular data item. So depending upon the requirement, depending upon the transactions, you may lock it at the column level, or you may lock it at the tuple level, or you may lock it at the page level, or you may lock it at the database or table level. All right. So more as high as you go in the granularity level, the concurrency allowed will be very less. For example, if I allow the locking at the field level, even in every record I can have, or in every single table, I can have many locks. So if there are 10 columns in my record, they can be locked independently. so that 10 transactions can work on my tuple. Whereas if you are having the granularity level at the tuple level, when a transaction is accessing a tuple, no other transaction will be allowed to access any of the subcomponents of that particular tuple. So if you put it at a table level, then nobody else can access your table. Only the admin can access. So these are the different points associated with the multi-granularity level locking. Any questions on this? Rahul?
Yes, sir.
Yeah.
Yes,
Any
sir.
questions?
Clear, sir.
What is this MGL locking? What
No,
do you
it's
mean
clear,
by
sir.
granularity level? What is granularity level? Rahul Mohrana. Okay. Rahul, if you are not unlocking the mic, how you will be audible? You are audible.
Yes, sir. Is it clear, sir?
Yeah. What do you mean by granularity level?
The level of hierarchy of locking and unlocking, sir.
Okay. The unit at which you can do locking and unlocking is actually called the granularity level. So at the lowest level, you have the field, then you have the tuple, then you have the table, then you have the highest level, you have the database as a whole. So in a database, if only one person can access the data at any point of time, then you call it as a single user centralized database. If you can have many people access the data, then you call it as a multi-granular database. All right. So this is very important. I think you have done some exercise in the last class also regarding the message communication that is happening in the locking protocols. So you will be evaluating or you will be comparing those protocols based on the number of messages generated and sent additionally for the purpose of locking, unlocking, etc. Now look at these analysis of the locking protocol. Please read these points. Analysis of the locking protocols. So finally, we have to identify the ideal size for the data item. All right. So what is the ideal size at which we can do the locking? So that is what is very important in the case of locking protocols. Whether we should lock at the field level or whether we should lock at the tuple level, table level, or at the level of few tables, or finally as a at the database level itself as a whole. All right. So one one common problem that is found in the case of locking protocols is actually the issue of deadlocks. So can anyone explain how these deadlocks are occurring in this case? Ria V. Ramesh, how deadlocks can occur in the context of locking protocols. Ria, absent.
Sir, hello.
Yeah. So can you just quickly recall how deadlocks are occurring in concurrent databases when you are following the locking protocol?
So when we are trying to uh, access read or write for one transaction, and that the same data item is being read after no so when we take exclusive lock on read data item X, and then the same X is being read in another transaction, the exclusive lock cannot be means we cannot leave exclusive lock until the transaction is completed. So then there will be a deadlock.
Okay. Any other answer? Open to all. Anyone else?
Sir, during cyclic wait scenario, it may lead to a deadlock if we have a transaction already holding a lock but trying to acquire a lock on another data. However, that data is being held by some other transaction, and its cyclic wait can lead to a deadlock.
All right. On the majority locking, I require 6 locks to lock a particular data item. 6 grand. I mean, out of 10 copies, I am looking for locking 6 items. So what happened is you have locked 5 data items, and I have locked 5 copies of the same data item. So I look for you to release one so that I can go ahead. And you will also be waiting for me to release one lock so that you can go ahead. So there can be the condition of circular wait as well as mutual waiting. So in the case of majority locking protocol. So the basic criticism against locking protocols is that they are susceptible to the problem of deadlocks. Any other questions? Any questions on this? All right. So we have locking protocols. So we have seen 6 or 7 different locking protocols. So the idea is they are also known as pessimistic protocols, where you lock the data item and then use and then unlock. All right. So the another the different there is another approach which is actually called the optimistic approach, where you assume that where you can go ahead with the concurrent access without locking the data item. You are confident that even without any locking, you can guarantee the consistency of the data. So you allow multiple transactions to work on a data item at the same time without putting any lock. So that is actually the optimistic concurrency control. So this also we have studied. Just quickly go through the points. OCC, optimistic concurrency control. Here you are not putting any lock, keeping the data item open for any transaction. Still you are guaranteeing consistency in the database. So OCC, no locking statements. And here you are using basically the timestamps for data items as well as transactions. Timestamp of a transaction is actually the clock tick at which a particular transaction has started its execution. So it will be incrementing in the positive direction only. So there is no question of 2 different transactions getting the same timestamp. So the read timestamp and write timestamps are for data items, and depending upon a condition, you will either allow, ignore, abort, or restart a transaction based on the comparisons between the read timestamp and write timestamp. So you will take a decision regarding whether to allow the transaction or whether to ignore the transaction or abort and restart the transaction. Any questions on this optimistic concurrency control? Here there are some more points on that. Please read what is this timestamp in optimistic concurrency control. So each transaction has a yeah.
Sir, while studying distributed computing, where says the timestamps may not be same as in a different machine. So how can we use that parameter for log?
Sorry, I am unable to hear properly. There is some echo.
Sir, what I'm saying is, in a distributed computing, the timestamps means the logical clock of different machines can be different. So how can we use timestamps for checking the which transaction is there?
You can use logical clocks, the timestamps from the logical clocks. Okay, we have studied two different types of clocks, vector clocks, Lambert's clock, and there are other types of logical clocks also, which are known as matrix clock, etc. So the timestamp can be taken from the logical clocks. All right.
Yeah.
Yeah. So the every transaction is going to have a unique timestamp, and it may be taken from the same system's clock, or you can run a unique counter, which is nothing other than our logical clock, and which is incremented by the scheduler. So you will be incrementing the local counter, a unique counter, which you will be taking as the timestamp for the transaction. So OCC, optimistic concurrency control, what is it? You can just read the slide. Okay, each transaction is issued a timestamp when it enters the system. So it will have a unique timestamp at the starting point, and timestamps are drawn from an increasing sequence of integers. The protocol will manage the concurrent execution so that it will be equivalent to a serial execution in timestamp order. All right. So the transactions will be, you have the set of transactions which are equivalent to a serial execution of them in some serial the timestamp order. And if two transactions conflict in the schedule, then the protocol will ensure that the one with the lower timestamp access the data items first. Now read about R timestamp and W timestamp, read timestamp and write timestamp. It is called RTS and WTS. Read timestamp and write timestamp. So there are two types of timestamps for every data item. One is actually the read timestamp and the other is called the write timestamp. And every transaction is having a single timestamp. That is actually the clock tick at which the transaction has started its execution. All right. So the protocol maintains for each data item Q. For every data item Q, it maintains two integers. One is actually the RTS, that is the read timestamp, and the other is actually the write timestamp. So here you refer it as R max Q, but you can take it as RTS and WTS also. Right? Rmax Q is actually the maximal timestamp of transactions that read the data item. Wmax Q is the maximal timestamp of a transaction that wrote the data item. That means who wrote in the data item last. So what is the timestamp of that particular transaction? So that will be copied and used as the timestamp of the data item. W timestamp, WTS or write timestamp, RTS. So if a conflict is prohibited, the transaction is aborted and restarted with a new or later timestamp. Whenever there is a conflict, the transaction is aborted and restarted with a new timestamp. All right. So we'll go ahead from here in the next class. This read timestamp and write timestamp. So we have studied these things in detail in the last class. I mean, in the last semester, but I think some of you were not present. So we will quickly, review the remaining topics under this, which is actually the serializability and this thing, the rules of optimistic concurrency control. Yeah, if you have any questions now, you can ask. Are there any questions?